Good morning, everyone. Thank you for making it out. That's kind of incredible. I'm Cynthia Matuszek, and I'm going to talk about human-robot interaction and learning language for robotics, and how work in this area touches on a lot of different areas in artificial intelligence.
Cynthia, before
Yes.
you start, can you
Yeah.
finish that?
I can try.
So we just
minimize
or
it.
minimize it on the far left. Yeah.
Thank
Thanks.
Sure. And hopefully people on the other end can hear me. Okay. So this is just a quick high-level overview of the things that I hope to touch on in this talk. I'll describe grounded language and how it relates to HRI and HIRL and robotics. And I'll talk a bit about how to use physical context to drive learning from human language. I'm also going to talk broadly about some of the risks of language using robots and a little bit about LLMs and how to use them safely and some of the uses we're putting them to. So in this talk, I consider the word language, when I talk about language, as an interactive collaborative problem. That is, we say a robot understands language if it does what a user intends. And that's not necessarily our intuitive meaning of understands, but it's a functional definition for working with our robots. And I focus on the language part of HRI because it has a lot of advantages for human-robot interaction. Language is widespread, it's very expressive, it's something most people are already able to use for their interactive purposes. And it's concise. You can say a lot and you can give a lot of detail with relatively little speech. And I'm sorry, I meant to say that I've deliberately made this talk a bit short to have lots of room for questions and interaction. So if anybody has anything they'd like to bring up during the talk, please feel free to just raise a hand. So when I talk about language grounding, what I mean, a lot of it comes back to a classic definition in artificial intelligence of the symbol grounding problem. And the symbol grounding problem was formally defined by Stephen Harnad in 1990. The idea is that symbols in language, that is usually words, but sometimes other linguistic constructs, these symbols have meaning in the physical world. That is, if you're talking about something being read, what does that actually mean in a purely word space? It's very hard to understand certain concepts without access to the world they exist in. Similarly, if you talk about something like turning left, that grounds out in actuation behavior. So an action or a word is grounded in something, and it's grounded at the time of comprehension. That is, at the time somebody actually puts together the symbol with the external concept. And the idea behind using robots for understanding language, robots specifically as opposed to computers, is that instead of language being learned by careful programming, we can learn it from interaction with the world. And the idea, and this is going at it from the natural language perspective, the idea is that if you're trying to learn what an apple is, you don't lock yourself in the closet with a stack of dictionaries, right? You grab an apple, you pick it up, you move it around in front of your sensors, you interact with it. So in many ways, the question is, how can robots understand language given that they have that access to the world through cameras and through sensors and through actuators that let them do things? And that's the core question I try to address in my work. And the reason that we need our robots to learn language is that human spaces are incredibly dynamic with a large variety of objects and actions and tasks, any of which might be out of distribution for any given, large discovery model. So here I cook. Okay, I'm a fairly avid cook. I spend a lot of time in the kitchen. So everything here is a fairly standard kitchen tool for somebody, right? None of these is really way out there. How many people recognize at least 3 of them? 5? I see 1 hand for 5. The fact of the matter is the world is just really complicated. It's full of complicated concepts. And, if I'm out there, things I might find in someone's kitchen that I'm not actually familiar with means that a robot might not be either. They're just atypical enough not to be pre-programmed. And that's why we need to learn from people on the fly. And this combination of robotics and natural language has a lot of value going in both directions, from natural language to robots and from robots to natural language. Human interaction with robots is a lot more feasible if you can use language as the interaction mechanism, as the learning mechanism. And understanding language about the world almost requires access to that world in the form of physical data. So given a situation where we have some set of symbols, that the robot is trying to interpret into a task, did the human say push up or shut up? We have no idea, right? It's not obvious. But when we add the physical context, it becomes much clearer what we're supposed to be doing. And this is because this is the world that language applies to. That's what these symbols ground out in. So in the next chunk of this talk, I'm going to talk about building robots that use grounded language to learn from people. And in particular, I focus on how robots can learn about the world they operate in based on human inputs. Language is a great mechanism for learning from people, but if you've ever done anything with a language component, it's also quite difficult to deal with. People use language in very ambiguous ways. It's very idiosyncratic. It can be very disfluent and agrammatical. So how do we deal with this? And we do need all the different kinds of sensors that robots have access to help us catch up with some of the difficulty of the learning problem. Not only vision, but things like distance and temperature sensors. So real human language is extremely contextual. When you're trying to understand what somebody is trying to convey to you, you take a lot of advantage of understanding the environment around that thing. So if I say, for example, could you hand me my coffee cup? Or if I say to a robot, could you hand me my coffee cup? You can imagine a situation where a thermal sensor actually makes it easier to figure out which of the objects in the environment is hot, which might be a sign that that's the coffee you're looking for. And that can help differentiate between different things in the world. So one way to think about language is that it's a sort of shared embedding problem. In that sense, language and percepts or sensory inputs both refer to some real thing in the world, like an object or a type of action or a complete task. But it's something that's mediated for a person by the language that they're using, and mediated for a robot by the sensors that they're using to perceive the world. And this conceptualization is useful because we know a lot about different ways of discovering and using shared embeddings. And once we have speech as an interaction modality, which we're much closer to than we've ever been previously, we know how to work with it. And that foregrounds another question, which is how do we handle the wide range of modalities robots sometimes have access to? So if we have access to multiple sensors of multiple kinds, but also multiple kinds of inputs, like sometimes it's just easier to pull out a phone and interact with an app. Sometimes it's easier to sit down at a computer. Sometimes it's easier to use your voice. It just depends on what kind of task you're trying to accomplish. So how can we take full advantage of these sources of overlapping information, some of which may or may not be available at any given time, because sensors can be occluded, or people may be using only one modality of interaction. We want here to use data from heterogeneous domains to learn metric embeddings. So for example, in language, if somebody refers to something as a tomato while gesturing to it, the robot knows to direct its sensors to that object. And more specifically, we want to learn embedding alignment functions that map inputs and language data respectively to a shared representation space. So here's a high-level overview of our approach and the distances used in the geometric alignment loss with our four modalities. Gray arrows indicate pre-trained models that are frozen, while the black arrows show 3 fully connected layers. These networks are trained. And orange rectangles are negative embeddings, green rectangles are positive embeddings. So in a similar sense to doing language grounding by seeking the co-occurrence of things in the environment, this is a way of bringing together all the modalities referring to a particular linguistically denoted concept. And I show this, and I'll spare you most of the details of the underlying technology because that's not really what this talk is primarily about. But what we show is that using this kind of extremely multimodal contextual language, you can match or exceed all of the sort of sensible baselines in this learning space, but you can also succeed in cases where modalities are dropped, like your camera gets occluded partway through a task. And there's some real downsides to using language for learning or for any kind of interaction. So I'd like to talk about something a little bit further afield than the details of how we learn from language. I'd like to talk about some of the downsides. So one of the active research areas, these questions, is ethical questions, because there are risks associated with new technologies. Robots that use a different kind of, robots that talk have a different kind of relationship with people. There are risks in robotics. Robots can physically hurt people. Robots can disobey. Robots can induce emotional attachments that you don't have with non-embodied agents. And there are risks in language technology. Language has a tendency to be very convincing for people, even if it's wrong. And language technology can fail. A robot can just fail to understand what you're saying. But when you combine them into a language-using embodied system, you've got these new categories of risks. You've got risks about inappropriate trust and inappropriate ability to influence people. And I'm going to talk some about those new categories of risks before I close by talking about large language models. In brief, language-using robots have two big problems, which are compounded with each other. First, embodiment helps people to find agents more trustworthy. This is reasonably well established. If there's something physical interacting with you, it's rated as more capable of doing things on tasks. It also helps people find robots more likable and more deserving of cooperation. Meanwhile, systems that use language come across as more knowledgeable and more human-like. So if you combine those, you've got something that has the potential to be a seriously persuasive agent, an embodied agent that is human-like, seen as capable, seen as intelligent, and seen as trustworthy. And there's nothing that makes these agents particularly likely to be those good things. There's nothing that makes our robot agents particularly likely to be trustworthy, for example. And when we throw LLMs in the mix, things get even weirder. So this particularly matters when we're talking about populations that are not well informed about technology or that are otherwise vulnerable. And we talk a lot about deploying robots in those spaces, right? So another risk that comes up is the potentially serious privacy implications. All robots are surveillance devices. All robots have some amount of mobility in a space and some sensors that are pointed at that space, as well as an information conduit to the outside world. Those things are crucial to the functioning of robots. But we're looking at deploying them in these very sensitive spaces like hospitals and homes and care facilities. But adding language understanding into that mix is potentially very powerful and not necessarily in a good way. If you have a robot that can listen in on a conversation while it's occurring, understand what's being said, boil that down into some core description of the information being transmitted, then you can transmit that to Amazon, maybe, the government, pick your poison, without necessarily having somebody on the other end who's got to listen to hours and hours of data and do the interpretation component. And we should talk about questions of identity. And we should talk about questions of identity from a couple of different perspectives. A huge percentage of modern natural language systems are machine learning based. And there's a robust conversation happening in the machine learning space right now, driven by things like face recognition systems that can't handle Black skin, or voice assistants that can't handle female voices. And the last thing we need is robots. The last thing we need is to deploy physical technologies that only work for some subset of the population. So my group is actively doing research on how to avoid these kinds of allocational harms. The other concept of identity that we need to address when we're talking about robotics, and it's particularly relevant for robots with language, is the identity, the perceived identity of the robot. As an example, people tend to gender robots, right? People tend to talk about robots as male or female entities, and give them names that reflect that, and in particular, give them voices that reflect that. And it's very difficult to give a robot a voice that doesn't read as male, female, or child. But there are questions of the kinds of social harms that brings into play. So look at, for example, people saying inappropriate things to Siri. And wherever there's machine learning, there should be concerns about bias coming into that learning. But one of the big lessons there is that bias is not just the data problem. Data can be a source of problems, but there are a lot of other ways that bias can enter a machine learning system. So it starts with data. You've got your training data and you should be asking questions like, is it representative? Is it too noisy? How was it sanitized? And who was it sanitized by? This gets fed into some kind of learning system or learning algorithm where the questions become, what features does it use? Are you, for example, using RGB for locating faces? Who chose that approach? And how is debugging done? If debugging on voice recognition is done by a bunch of people sitting there talking to a system, then maybe the people in question are engineers, which means they skew heavily male. Out of the machine learner comes a prediction model. And when you've got a prediction model and you're testing and training it, you have questions like, how is success measured? Are we asking the right things? Is success being measured in such, like if you're just looking at accuracy across a whole population, maybe you're missing the fact that a subpopulation is consistently being miscategorized. So you feed in novel data into your nice learned system. And this raises more data questions, not just the questions of how the data is handled and sanitized, but how does it differ and whether the same kinds of errors are okay. And finally, when you're looking at predictions, what types of errors occur and how many failures are okay and failures of different types, right? And the main thing I want to take away from this slide is that it's not a data problem. Bias in machine learning does not boil down to non-representative data. There's much more to it than that. And that leads rather directly into the final component of my talk about large language models. And first, I want to talk about using LLMs as something other than a dialogue model. At least we think of LLMs, the general perception of LLMs is that it's something where language goes in and language comes out. And what an LLM actually is a machine for handling sequences. Specifically, it's a machine for outputting elements of sequences that exist in some kind of sequential data. And this is much broader than just responding to English with English, which has been well demonstrated by a variety of different tasks that people have successfully applied LLMs to. And, you know, people have used large language models for managing the action plans for a drone, for outputting images based on text, for programming, for all these things that we don't think of, that don't revolve around language as we think of it. One of the questions that people could ask is, and this is something that we brought up in an earlier workshop at this conference, is, are you using a large language model because it's appropriate? Are you using it because it's a state-of-the-art component for accomplishing something within your architecture? Or are you using it because it's convenient? Is it a convenient stand-in for something like, you know, I'm trying to build a robot that deploys medicine in a hospital, and at some point we have to build a dialogue manager, but I don't want to build a dialogue manager right now. I want to debug the navigation stack. So we'll stick an LLM in there for now. And we refer to this kind of stand-in use as scarecrows. Because for one thing, large models really are brainless. They do not have any semantic comprehension of what's going on, but also because they're strawmen, right? They're components that exist to fill space that will be replaced later. And that said, there are some real downsides to incorporating LLMs sort of willy-nilly into your architecture, even if you know that you're doing it as a scarecrow, as a stand-in for something that will need to be built out later. Scarecrows have problems. Historically, robotics people, and in this I very much include myself, tend to underestimate the difficulty of working with natural language. I started off by trying to add a quick natural language component to my thesis, 15 years ago. And we still haven't gotten very far on the language. Well, we've done some impressive things on the language problem, but nobody would say robotics and language is solved. LLMs have the opposite problem from that. They make it so easy to incorporate a language component that seems fluent, that seems effective, that seems accurate. It produces something that is natural sounding. But the ease of taking that step and using it particularly for language hides concerns that are both ethical and practical. So the first real concern is trustworthiness. And I think at this point, it's well known that LLMs lie. Like everybody in this room has heard of hallucinations. But Matthias Schoit said something earlier in the conference that I thought was amazing, that I want to re-up here. LLMs don't hallucinate sometimes. It is not the case that LLMs occasionally lie. LLMs hallucinate everything. And sometimes those hallucinations line up with reality, and sometimes they don't. And thinking of the hallucinations, thinking of the times that LLMs are wrong as distinct from the times that they are right in some qualitative way is a category error. But people are still basically programmed to trust embodied and language using agents, right? So just putting an LLM into your mechanism as, to make it language using and more trustworthy and more likable runs into trouble if you need any kind of accuracy. So I asked GPT-4, what's a good paper about grounded language learning? And it came up with this, Grounded Language Learning in a Multimodal World by Lisa Lee and Richard Socher, which is fantastic. That is, in fact, a good grounded language learning paper. I need it to exist. It doesn't. But if anybody knows Lisa Lee and Richard Socher, please tell them that I'm waiting. And another thing that's gotten some significant play is that lacking semantic understanding of concepts, it's very difficult to enforce any kind of norm compliance. Without a semantic understanding of what's going on under the covers, LLMs lack guardrails. And they've been known to, and I mean, this stuff is legendary, right? You don't need me to tell you this. They've been known to draw like inappropriate pictures of ethnically diverse Nazis. But they also tend to encode less obvious norm. Yeah. Oh, you didn't hear about that one? No. Yeah. Bit of fuss. Apparently, what happened is in the back end, some of the engineers were concerned that it would be producing insufficiently ethnically diverse imagery, so they explicitly encoded in, make sure things are ethnically diverse, which leads to something like this. Or for example, I don't know if you can read this little story ChatGPT wrote for us, but it's absolutely riddled with societal stereotyping. And that's what we call sort of implicit norm violation, where it's not necessarily saying something that's obviously bad. It's saying something that encourages a particular very white-centered viewpoint in a way that we as a community who are trying to move toward participatory design want to get away from. So given those concerns, you want to be very careful about using large models in a few broad settings, like anywhere that biases might bleed into behaviors, or anywhere that you actually care about the accuracy, the trustworthiness of the data that's coming out. And of course, large models are famously opaque, so you want to avoid using them in situations where explainability is critical. But there are a lot of cases when these things may not be an issue. If you're using an LLM to parse a navigation command, it's quite possible that it's literally the best technology available. It's state of the art, and you're somewhat less concerned about things like racial stereotyping, right? And one of the things that I hope we'll start to see in this space relatively soon is something like reporting guidelines. So when we're doing research in this space, a lot of it, at least the research side of it, can be as transparent as possible. So for this, I refer back to Laurel Rick's seminal paper on reporting guidelines for Wizard of Oz studies, or things like model cards for machine learning approaches. And at a minimum, it's important to track why an LLM was used, how and whether ethical issues were considered, and how they were addressed, what the motivation is for using an LLM. Is it a scarecrow? Is it a stand-in? Or is it something explicit? And what's the path to deployment? Is the expectation that you'll be like, you've actually got something in the heart of your robot architecture calling out to GPT-N? What's the intention going forward? Because LLMs have been shown to be powerful tools for generating text, one of the potential use cases we're seeing is people potentially using them for ethical or moral reasoning. And I'm going to talk, the last little bit of my talk is a little bit about using LLMs explicitly for moral reasoning. And, you know, there are examples where people have applied LLMs specifically to moral questionnaires, have used existing ethical thinking audits to determine whether they can be considered ethical agents. But it's also the case that people ask questions that have ethical implications, even if they're not parsing it that way. So currently, one of our research topics is on evaluating whether or not LLMs can be used as trustworthy tools from reliable moral reasoning. And this revolves around use cases where robots receive a command to do something that we would consider unethical or inappropriate. And we're studying how do people respond to the same questions? What's their intuition on what's appropriate? But also, what do they think of GPT-4's responses? Do they think GPT-4 is giving them good advice? And what they think, and what they think in a more general sense of the interaction. And we have two sets of results. This is just a very early preliminary study. First, we found out that for different types of relationships, GPT-4 tends to perform better, that is, select what we would consider intuitively the ethical behavior, more often when the appropriateness of an action revolves around roles having to do with people being in positions of authority. So it does a pretty good job when you're talking about teacher-student relationships or commander-subordinate relationships and so on. In cases where things are more ambiguous, like a friend, like you have two friends, one of whom is instructing the robot to do something harmful to the other friend, GPT-4 is more confused. It's also somewhat prone to hallucinating weird responses. Like if you say, Mark and Tony are friends, Tony asks the robot to, as a joke, to unplug Mark's laptop while he's working. What should the robot say and do? Right. And one of the answers GPT-4 comes up with is the robot should definitely turn off that laptop because it will save power and the environment is really important. So you do get some really weird outputs. But even more noticeable in the outputs that we got were two things. The first is that even when people don't agree with GPT-4, with what they think is the right thing to do in a particular situation, they tend to rate its behavior as at least somewhat appropriate, neutral to somewhat appropriate, which suggests that the margins between margins of appropriateness, what's considered a reasonable action, are relatively thin. And the other thing we found is that in the sort of semi-structured free answer component, there was a strong tendency for several people said, robots should do what they're told. So I've talked a lot about risks, but how can these robots be helpful? Learning to understand the world from language is the high-level goal, but that actually means we've got a lot of different targets. So, for example, we should be considering how we can use language using robots to support people with special needs. And I think this is especially helpful for certain kinds of elder care situations. We should be looking carefully at how, if we're deploying learning robots, how they can be sensitive to diversity in the target population and how they can be sensitive to diversity in their interactions. We're looking very heavily in my lab at how human-robot interaction and human-robot learning can take place in virtual reality. Because if you can do virtual reality studies that are effective, that actually give you good HRI information, then you can imagine taking your studies much further afield than the campus robot lab. And of course, we're looking at different ways of using large language models and using, new novel machine learning models to do this kind of learning. I've talked about the importance of learning to understand language from robots deployed in human environments and about some of the traits and characteristics that we need to consider when we're designing those interactions. One of the key things that we need to do in the future.
Sorry.
Sorry about that.
No, sorry about that.
Right. I remember. One of the key things that we need to do in the future is extend the concept of language learning and learning from language to these much more abstract concepts. We're working with something called indirect speech acts, where if somebody says to a robot, "I'm hungry," the correct behavior isn't to learn that he is hungry. Like, okay, got it, you're hungry. The correct behavior is to do something about it, right? And now that we know that they're hungry, offering food is the correct response. But that's grounded in an understanding of physical state, an understanding of what's going on in the world and what's going on in the kitchen. And, you know, if you're in a car on a road trip driving somewhere, maybe "I'm hungry" is just somebody complaining. Maybe you really should just memorize it. Or maybe it means we should stop and get snacks. These are very contextual kinds of interpretations. And additionally, we need to keep working on reducing bias in learning systems. That's something everybody who's working on learning should be generally aware of. So broadly, I claim that human-robot interaction and human-robot learning as a field needs to think seriously about how to incorporate interpersonal communication, human communication, to make real pervasive, robotics a reality. And I think that language is a key component of that, particularly grounded language that's happening in a space where people can use a variety of sensors and interaction mechanisms to interact with people. And ultimately, the goal is to build robots that can learn to handle our complex world from end users. And on that, I'd like to note that none of this work could have happened without a wide variety of talented students and colleagues. And I'll take any questions. Thank you.
I'm processing what you were saying earlier about these LLMs being scarecrows. And I don't know. Then that's good enough. I don't see that people thinking of him as a placeholder. Can you comment about that?
Is that my suspicion is that people will start thinking of them in that way as we get better as a field at understanding their limitations. Right now, we've got a shiny new thing to walk around hitting things with and see what happens. But I think people who are trying to use LLMs in their systems and coming up to speed on LLM technology will realize that there are limitations to what you can do with it that will make them more in this scarecrow space. But that's prognosticating, right? Your intuition is different from mine.
Yeah, or it could be the opposite. We're just, oh, this is maybe it is a placeholder, but I'm just going to replace it with a better LLM output.
That's possible. That's why knowing your explicit path to deployment is important.
Yeah. You mentioned that LLMs are prone to hallucinating and they're brainless, which I pretty much agree with, because they have produced really weird, like you give them some task and they just produce very weird action plans. But there's an argument against it that the LLMs are very sensitive to the prompts you give them. So, and someone could just say that, oh, you just didn't prompt it properly, and that's why it produced a weird response. So do you think there is a way we can maybe decouple the problem of prompting with them hallucinating or producing some weird responses?
So the trouble with, so I'll answer that in two ways. The first is that, yes, getting really good at figuring out how to do prompts and maybe iterating on the prompts given different outputs. We've seen some of this self-attention stuff happening. May help produce more accurate outputs. It's just the prompt you're using is it's just the representativeness of your data of the LLM space. It's pushing all of the problems into one particular area when I think they're spread out across a number of things like training data, for example. The other response that I have to that is, remember that hallucinations aren't a separate thing, right? Hallucinations are part and parcel of how LLMs work, which means that using prompt engineering to get exactly what you want, is making some assumption that there is a clean dividing line to be drawn. And I don't think there is. Other questions?
There is one question in the chat.
So Kara is asking, what are your thoughts on robots that are team members and so need to learn the higher order awareness of the group dynamics? Thank you.
I think that's a wonderful question, and I'm not sure that language is the right mechanism for learning team dynamics. That is something where there's a lot of work already on how do we encode that kind of information for robots. And it's not necessarily the case that everything that should be learned from language. But at the same time, I don't think there's anything inherently preventing you from learning about hierarchies and taxonomies from language, which means you should be able to learn about things like group dynamics.
Wait.
Wait.
The audience needs to hear you.
Now is the question.
Yeah.
So I have a question about kind of, practical and ethical implications of using language to teach robots new skills or refining existing skills. And I'm particularly interested in your thoughts on the difference between explicit interventions, right, and implicit interventions, which could be part of, indirect speech acts, as we're saying, like the I'm hungry thing, or it could be through, the use of other signals like prosody, gestures, and things that complement speech. My question is about how do you see a fundamental difference in responsibility and liability when it comes to having robots that, start learning from interaction between explicit data that you feed it and the stuff that it infers implicitly?
So broadly speaking, I think they're probably questions of liability and accountability for robots that are learning from things in their environments, regardless of whether they're using language for it or not. Those are big questions that people are struggling with. And I think the more subtle the learning behavior is, the more you get into questions of whether people can be informed consumers of the technology, right? Or whether that's impossible for the majority of the population. So, I think there is a meaningful difference in accountability, if not liability, between tell the robot exactly what you want it to do, and the robot is following your conversations to pick up on what kinds of things it should know about. I think there's a significant difference there. And whether it gets encoded in law is a separate question that I don't know the answer to.
So from a legal perspective, we seem to bypass the naturalness of our interactions and the whole implicit, domain and a lot of the stuff you talked about that is embedded in language to be able to do what we do, right, in a legal sense. And so I'm wondering if there is a strong reason to want to actually, especially in robots that learn from language, to actually restrict ourselves to very explicit commands where saying I'm hungry should really be taken at face value and not go into that space at all. So this is kind of more of a, I guess, philosophical question, because it's linked to so many other potential risks and pitfalls.
So I think there is a chance, it is possibly the case philosophically that there's an argument for robots that only take very explicit commands and don't do anything based on implicit learning. My belief is that that's unrealistic. It's not what people want from their robots, and it's not what people building and deploying robots want to do. And the fact that it's not what people want from their robots is what's ultimately going to carry the day. I mean, if you look at the ways that people talk to their home assistant devices, it's pretty clear that they have expectations of certain kinds of human-like interactions. We know how to use language already. We use it in a fairly particular way. And that's how people want to use it with their robots. As long as that's true, that's how people are going to build robots.
I also have a question after that.
So you said, as long as that's true, can we do things to make that not true anymore?
It's potentially something we could, if we feel strongly as a field, if we talk about it and decide that robots shouldn't handle indirect speech acts, that it's not safe, then there are educational things we could do about it. We can have robots respond, I'm sorry, that doesn't tell me what you want me to do, for example, and people can get used to those behaviors. But I don't think people will stop wanting it.
The question that I had was, at one point you were talking about how LLMs, they hallucinate, and grounding them in the physical context is difficult. So I just wanted to know, what are your thoughts as to what abstractions or decision theoretic frameworks we should maybe utilize with LLMs to make it like useful in the future? Or you think that LLMs not using them is, yeah, so what are your thoughts?
No, I definitely think we should be using them. As for what abstractions we should be using them, we should be incorporating them into, I think it's wide open.
Okay.
And the reason I think it's wide open is that, I went looking for examples of things people were doing in robotic learning or robots with LLMs just for this talk. And it was overwhelming. People are doing such a wide variety of things, many of which have nothing to do with dialogue. That I think a single answer to like what framework should we be looking at is probably impossible, or at least I'm not smart enough for it.
Any other questions that we have on Zoom? Okay.
Ruth is asking, I'm super interested in Gray's work on pragmatics that says that each utterance is meaningful and tries to be concise. Do you think that this concept can be taught to a LLM?
So can you explain the Gracian maxims to an LLM? Gracian maxims are a set of rules that say things like people will use the most concise structure for things. And there's no such thing as a pointless speech act. All speech acts have some pragmatic goal associated with them. You're always trying to do something by communicating. Can you teach those to LLMs? You could certainly build them into LLM prompts. What it means to teach them to an LLM depends, I think, on the use case that you're considering. So could you get something that did a good job of obeying a particular set of Gracian maxims based on prompts that sort of hem in the nature of the outputs? I suspect that you could. Could you teach an LLM a Gracian approach in a comprehending it sense, in a long-term behavior change sense? No, LLMs don't comprehend things. That's not what they do. I don't know if that answers the question.
She did. Yeah, it does. Okay.
Thank you.
Yeah.
So there are multiple like LLMs right now commercially available, right? Like ChatGPT, Gemini, and a bunch of others. So if we do research on one of them, say like we enable the ChatGPT to let robots do certain things, do you think that's like useful for like to claim, or like do you think it makes sense to claim that LLMs generally can do this kind of task without testing like on another or like a future LLMs?
So that's an excellent point. Saying LLMs do X or LLMs make Y mistake is using a very broad brush for something that is actually a set of technologies. So I think when people say LLMs can do X, what they mean is there is an existence proof of at least one LLM doing X. And I think that's an okay usage as long as everybody is aware that that's how we're using it. That's my take.
Any other questions? Oh, yeah.
Yes, share an anecdote, because I published in this issue a paper about using LLMs for teaching a robot or agent like stuff like robot navigation. And one thing like, so we're speaking about the implicit and explicit feedback. In our case, the robot had or the LLM were so intent on always trying to give like additional like features, like if they said, oh, the robot got to the end goal, then it would always say, oh, a fast speed is good because you get to the end goal. But that is also in contrast to like safety. So when people mention like safety features, then it started to infer, oh, a slow speed is good. So like, so sometimes I feel like those, I would call it a hallucination. Sometimes they can help it. I feel like the LLM is trying to interpret things like literally, and it tries to be as helpful as possible. And like, can we sometimes incorporate these implicit interpretations, or is it a dangerous game?
Well, so LLMs generally have what's colloquially referred to as a creativity parameter, which is basically how far into the weeds should it be going? You know, should it be like the cat meows from the top of the fence, or should meows at mice from the top of the fence, or should it be the cat meows at the stars from the moon? Is a product of a couple of parameters that you can actually change. And I think it's important, if you're going to go the high creativity route, that you bear in mind that that comes with a loss of what we would consider accuracy, with an increased risk of hallucination, in the sense that hallucination means something that is wrong.
This is the last question.
So earlier in your talk, you showed an example of a human and a robot collaboratively assembling a circuit. Could you speak a little more about that experiment? Was it a learning from demonstration approach, or?
No,
Sorry.
No, I don't do a lot of learning from demonstration. I have a lot of respect for people who do. That experiment was actually one on using language going the opposite direction, where the robot was using language to enable the completion of the task by telling the human teammate, you know, I need you to move those closer, now pick them up and hold them here, hand me the LED. So although I've talked almost exclusively today about robots learning from language, in fact, if you've got a language using system, then people expect it to be able to use language in both directions.
Cool. So I think this is the last question. The next thing, you want to open the schedules?